If TSMC stopped operating tomorrow, the AI industry would collapse within months, not slow down, not struggle. Collapse. No new GPUs. No new AI chips. No new smartphones. No new data center processors. The entire physical layer of the modern economy. Frozen. And there is no backup plan. NVIDIA generated over $130 billion in revenue last year. Apple designs the most efficient consumer chip on the market. Google built custom silicon to train its own AI models. Meta redesigned its entire data infrastructure from scratch. None of them manufacture their own chips. Every single one ships their designs to a single company on a 14,000 square mile island, and waits. That company controls approximately 90% of the world's most advanced semiconductor production. Its name is TSMC. And the fact that most people have never heard of it is exactly why this analysis matters. TSMC stands for Taiwan Semiconductor Manufacturing Company, founded in 1987, built around a concept that seemed almost naive at the time. Manufacture chips for other companies, without designing any of your own. That model has a name: Pure Play Foundry. Designing a chip and manufacturing a chip are two completely different businesses. Design requires software talent, hardware architecture and intellectual property. Manufacturing requires multi-billion-dollar factories, ultra-precise chemical processes, and decades of accumulated operational knowledge. TSMC said we will do only the second one, and we will do it better than anyone trying to do both. The rest of the industry took 20 years to fully understand why that was the right call. Without TSMC, an NVIDIA chip is engineering software. With TSMC, it becomes functional silicon. Its 6 largest customers, Apple, NVIDIA, AMD, Qualcomm, Broadcom, and MediaTek, collectively represent the majority of its advanced node revenue. Advanced nodes, 7 nanometer and below, account for roughly 60% of total revenue. And here is a number worth holding. AI-related demand has gone from near zero to an estimated 15 to 20% of TSMC's total revenue in 2024. That number is accelerating. The revenue model is simple on the surface. One layer deeper, it becomes one of the most defensible business structures in global industry. Simple version: TSMC charges per wafer. A 300mm silicon wafer on a 3nm process costs roughly $17,000 to $20,000 to produce. TSMC sells it with margin. More demand for advanced nodes means higher price per wafer and higher margin. That is the core loop. Now the structural layer. Every new node generation requires a completely fresh capital investment, $20 to $25 billion per advanced node fab. That is not a rounding error. That is the GDP of a small country, deployed into a single manufacturing facility. But here is the economics that make it work. Marginal revenue on that investment increases with volume. Once a process reaches maturity, gross margin can exceed 60%. 60% gross margin. In a factory business, most industrial manufacturers operate at 20 to 30%. TSMC's advanced nodes run at 60. That is not an accident. That is the result of being the only viable option for the customers who need what you make. In 2023, $76 billion in annual revenue, 54% gross margin, 42% operating margin, revenue growth averaging 18% per year over the prior 5 years. These are not tech company metrics dressed up in industrial language. These are genuine industrial metrics that most tech companies would envy. Beyond wafer fabrication, there are 3 adjacent revenue streams that most analysis overlooks. The first is process design kits. TSMC does not just fabricate, it gives customers the exact rulebook for designing a chip that works optimally inside its own processes. Every engineer at NVIDIA, Apple or AMD, who designs a chip for TSMC's 3nm node is working inside a framework TSMC built. That creates technical lock-in that goes far deeper than a manufacturing contract. The second is advanced packaging, specifically CoWoS, chip on wafer on substrate. This is how GPU dies connect to high bandwidth memory in AI systems. Every NVIDIA H100 deployed in every AI data center today uses TSMC's CoWoS packaging. This is a high-margin, fast-growing revenue line that extends TSMC's reach beyond the wafer itself. The third is vertical diversification. Automotive, industrial, high-frequency chips, all on mature nodes, all with stable demand cycles that run counter to consumer electronics. When smartphone demand drops, automotive does not. This is not just revenue. It is a structural hedge against cyclicality. Now the cost side. Because this is where the barrier to entry becomes concrete. TSMC spends between $32 and $36 billion per year on capital expenditure. That is 40 to 45% of revenue being continuously reinvested. Intel runs a similar ratio but off a smaller revenue base and with far worse operational results. Samsung invests heavily but splits capital across memory, consumer electronics and foundry, which means foundry never gets full priority. TSMC reinvests 40 cents of every dollar it earns. But the most revealing cost is not the total number. It is the equipment line. A single EUV lithography machine costs between $150 and $200 million. It is manufactured by one company, ASML, in the Netherlands. And it is the only tool in existence capable of printing transistor patterns at advanced node scale. One fab needs 20 to 30 of them. ASML produces around 50 per year, globally. For everyone. There is a waiting list. And that waiting list is, functionally, a multi-year barrier to entry for anyone trying to catch up. Add to that the human cost process engineers who can operate at this level take years to train. The learning curve from new node design to stable production runs 18 to 24 months under optimal conditions. Capital, equipment, talent. Any one of these is hard to build. All three together, at TSMC's scale, that is what makes the gap real. Now the competition. Because the gap is larger than the industry publicly acknowledges. TSMC is in commercial production at 3 nanometer today, with 2 nanometer ramping through 2025. Samsung has nominal 3 nanometer production. Intel Foundry has not demonstrated stable commercial production at an equivalent node. But the node number is almost secondary. What matters is yield. Yield is the percentage of functional chips per wafer. If your process produces 70% functional chips and TSMC's produces 90%, that is not a 20-point gap. That is the difference between a viable business and an unviable one. Samsung's 3 nanometer yields are reported to be significantly below TSMC's. Intel's foundry yields at advanced nodes have not yet been demonstrated at commercial scale. But there is a second layer even more important than yield. Trust. TSMC is a pure-play foundry. It does not design chips. It does not compete with its customers. Samsung does. It makes Exynos processors. Intel does. It designs its own CPUs. When Apple or NVIDIA deliver their most sensitive chip architectures to TSMC, they are not handing a trade secret to a competitor. That dynamic cannot be manufactured by policy or investment. It has to be earned over decades. And then there is the ecosystem: design tools, libraries, process documentation, all optimized for TSMC's processes over 35 years. Switching to Samsung is not a procurement decision. It means re-engineering the chip from the ground up for a different process, then accepting unknown yield risk on a product where failure costs hundreds of millions. Realistic timeline for Samsung or Intel to reach full parity, 5 to 8 years, minimum. Assuming flawless execution. Neither has a clean track record of flawless execution. Now the risks. And there are real ones. The most discussed is geopolitical. 90% of TSMC's advanced node capacity sits in Taiwan. The People's Republic of China claims Taiwan as its own territory. That sentence alone is why the United States government passed the CHIPS Act in 2022, $52 billion in subsidies to rebuild domestic semiconductor manufacturing capacity. TSMC is building fabs in Arizona, Japan, and Germany. Here is the structural assessment. Even on the most optimistic timeline, advanced node capacity outside Taiwan will not exceed 20 to 25% of total global supply before the end of this decade. The geographic concentration risk is real. And diversification is moving slower than the headlines suggest. A full disruption scenario in Taiwan would affect not just semiconductors, automotive, medical devices, defense, telecommunications. Estimates of economic impact in an extreme scenario run between $1 and $2 trillion annually in the first years. That number is not alarmist. It is what happens when a single point of failure sits at the base of the modern economy. The second risk is cyclicality. Semiconductors cycle hard. TSMC uses long-term contracts and advanced capacity commitments to smooth it. But 2023 showed the limits of that cushion when PC and smartphone demand contracted sharply. Third, customer concentration. Apple represents approximately 25% of TSMC's revenue. That is a single point of commercial risk in an otherwise diversified industrial business. Fourth, and longest-term technological disruption. If an alternative to silicon transistors, graphene, integrated photonics, quantum architectures, reaches commercial viability, TSMC's process advantage becomes less absolute. This is not a near-term threat, but it is not zero. So what exactly is TSMC? It is not a monopoly in the legal sense. Alternatives exist. They are simply inferior, by a margin, the market has judged as commercially unacceptable for the chips that actually matter. It is not a temporary leader. TSMC's advantage was built over 35 years of consistent capital allocation, extreme process specialization, and a foundational decision, made in 1987, to never compete with its own customers. That combination cannot be replicated with money in 5 years. It probably cannot be replicated in 10. What TSMC is structurally, is a systemic bottleneck at the base of the AI economy. Every large language model needs chips. Those chips need transistors at sub-nanometer scale. That scale only exists commercially in TSMC's fabs. The question is not whether TSMC can be replaced. The right question is how long the world can operate with this level of concentration at a single point in the global technology production chain, and whether the current pace of diversification is fast enough to matter before it does. The answer for now is clear. The dependency is more durable than most anticipate, and the risk is larger than most acknowledge. TSMC does not manufacture the future. It manufactures what makes the future run.